Okay, yeah. Jensen, just one click and I think we are live. Yeah, welcome everyone to our Perfect Sample Gas webinars. And a warm hello from Singapore and from Germany. James, that was kind of nice that you shared the same situation or the same feelings I had. I think this is already webinar number 22nd, but still we are kind of nervous, and I think there's a pretty good reason because we saw that more than 200 people signed up for this, and
Wow.
yeah, this is yeah. This is something we never thought we could achieve. And I think we never made a secret out of this, that this really gives us a strong push to improve the quality, um, to give you even more details and more insights. And at the end, to be very thankful that so many people are attending this and give us the chance, not just for our products and for the solution, but maybe to give a little bit an insight of a niche application, an application of with sample handling components, which are so important.
Mhm.
So I think, Jamson, we can be very thankful for this development, right?
We are highly appreciative. I think we
Yeah,
come a long way. More than half a year. In fact,
yeah,
we were discussing about the next fortnight. It was exactly 6 months after we doing all this webinar for this year.
yeah,
You know,
yeah,
and I was thinking, the next webinar that we should recap all those that we have done for the entire from January to all the way to May.
yeah,
The last Thursday of May. So we recap all the important pointers, right? So that many people who missed any of the sessions, they can now sort of pick up, right, a summary from the last sessions.
yeah, yeah. I think
Yeah.
that's a great idea. Okay, Jameson, before I introduce you and me, maybe we do the following, because that would be something I would really love to see. Um, we found out that now there's so many people from all around the world, really all around the world attending. And I always feel, Jameson, I think you can confirm this. Um, we are kind of a small family. I mean, if we look at analyzer technology, it doesn't matter if we talk about process analytics or if we talk about emission monitoring. When you go, to the conferences, or when there's a trade fair or something, you always kind of see the same faces. It's really like I sometimes feel it's like a family. And
Yeah.
maybe I would like to invite everyone just to say hello in a short message. Just say hello, and maybe you can say the country where you're from, and maybe you can also say the city where you are living. That would just be awesome, because then everyone can see in the chat, that we are one community. And yeah, at the end, sure, the topics are similar, and I would really love to see that. So, um, guys, please be so kind. I said hello and welcome from our side, and would just be perfect if you can write a short comment on LinkedIn and say hello to everyone. That would just be superb, I would say. Okay, yeah, but Jensen, we got a lot of topics to talk about today, so let's not. I wouldn't say waste more time, but that gives me the chance to introduce you. From Singapore, this is Jensen Chang, our vice president, and I would also like to say hello. My name is Jörg Ehrens. I'm the managing director of the company AGT-PSG. And I must say it's again another topic I really like. When we were in the preparation for this webinar, we were discussing so many things, and again we have this super big pressure to put into 60 minutes a super important topic. Maybe I think, Jemson, we had kind of, I mean, that there was more kind of a joke. You were the architect for the title, right? so yeah. I mean that. I think it's more than fair to say who is responsible for what. And the heart of the sample handling system, the gas cooler. Why do you say that?
Well, I think in the on the probe itself, we normally use it in our own in-house. We call it it's a sampling, and then after sampling from the sample probe all the way down from the heated line, and then we go to the gas conditioner. So the sampling system or the gas conditioning system or gas handling system is just a terminology. And you see, the gas cooler itself is really an art of the entire configuration. And it's also, it is the most expensive component, individual component, as far as price is concerned, you see. So why we say the heart? Because basically, it is so critical that we make it right. Whether we want to choose, we have a choice to have a strong heart, or we have a choice to have a weak heart. You know, if you have a weak heart, what does it mean? We have a lot of attention, we have a lot of things to do. So therefore, over here, I like to say the heart of the sample handling system or heart of the sample conditioning system, I like to justify in this webinar, the following in a short while. Yeah.
Yeah. Okay. That gives us even more pressure to explain this in the most accurate way. And I mean, I think also when we look at the feedbacks we got from the people who are attending our webinars, we can see that there is different level of let's say skill sets, of maturity. There are some people who are already super long in this field. You know, when we posted this video, I think it was the second post of this video. Maybe I can shortly show this here.
I can use continue from my.
Oh yeah, here. I was super. I remember when you shared this video with me for the first time, I was thinking, hey, what is this? And who can understand what this is? I mean, it doesn't show a lot. It only shows a very small sneak. And but still, we got so many comments and so many people who were actually looking at this and had the absolute right idea what is happening there and what should be done. And I really have to admit that I was also impressed, by this support and by this help from this community, because you shared this there, and then so many guys were answering with their comments and with their hints what can be done there. And I think if we can really kind of establish something like this, that would be perfect. Okay, but Jemson, I think we are way too excited, and I think we have to be a little bit more structured of what are we going to talk about here now in this webinar. Because you said the heart, and we already started to talk about probes and heated lines, and it really makes sense to put all of this into a picture. So that people can understand what are the components of a sample handling system, why is this so relevant, and why is the cooler in cold conditioning systems so important, right?
Yeah, and you were saying that, so you see, many times this gas cooler, other people would like to call it, a dryer. Nothing wrong, right? Some even people call it a gas stabilizer. Yeah, I do have customers who call it a gas stabilizer, and after some thought, and after I find that, hey, this is true. It is a gas stabilizer, because you can see that, when the pump sucked in and it went into the exchanger, it stabilized. There are many things that is stabilizing it. The first thing that we are talking about the gas cooler is to produce a stability of a constant dew point. Isn't it a stabilizer? You see? So having a reliable constant dew point, I would say we're talking about the over here, it has an impact on the gas analyzer calibration. You see?
Yeah.
And any of the gas analyzer calibration, they need to have a good repeatability, and they like to have a good reproducibility of the results. You see? So
I think, and this was also very interesting when we put up the poll on our LinkedIn page. I mean, the question was a little bit, I wouldn't say a mean question, but it's very hard if you can only choose one option. It's very hard to say what really defines the performance of a gas cooler. Most of the people who answered our poll, they confirmed that it's going to be the dew point stability. So the outlet dew point stability. So stabilizer is really, that's a nice word. That's a good background. Okay, but Jameson, let's go back one step, and maybe we share with the next slides on the PowerPoint. We give a little bit more overview, I mean, this graph really shows why is a dryer in our line of process. We will share on P&ID pretty soon. But when we look really at the probe, when we look at the heated sample line, and the cooler as a conditioning system, why is this so important? And stabilizing is one good thing. And in this graph, we share that the interference with other components, with components which want to be or have to be measured, that this can, if there is a lot of water in the gas sample, in the gas we want to measure still remaining, and this then can cause wrong results. Would you agree to this?
Yes. In fact, that some questions arises in the midst of this practical experience. Is that, just for the audience, have you ever, on the analyzer itself, where you measure SO2, especially for SO2, and the plant shut down, even though it has been a few days already, it shut down, but yet you can see that there are some reading on the SO2. Have you ever asked why it is still there, an SO2 reading, even the plant has shut down? Is this due to the memory, or is this due to the water? There are also incidents whereby, for the maintenance personnel, whereby you can see that the rotameter, the flow meter at the just before the gas analyzer, you can see it's pretty sticky. The ball, the indicator sticks to the glass, and for the maintenance people, they have to create some light vibration in order to see to regulate the flow. But what is the reason for all this? You see, this is why I mean by the heart, because if the heart is weak, the water carry over. Not a pump itself is important, but there are also many other factors which I'm going to present over here. You see, So of course, generally, this chart has addressed about cross interference, but there's another reason why a gas dryer, a gas cooler, it is fundamentally used on the cold dry system is because the environmental reporting has to be reported in milligram per normalized meter cube. You have to be reported in dry basis. So there is another reason for normalization. You see?
Mm-hmm.
Yeah.
Mm-hmm.
So,
Okay.
so however, the good things is that generally in the public, gas cooler, people generally choose a gas cooler because of one reason: it has a very long lifespan. Right? Just remember to do one thing is to replace the peristaltic tubing on time. There's only just one thing, and it performed. Have you ever, remember our house, our home refrigerator? When was the last time it breaks down?
Yeah.
I couldn't remember. So it performs there. You see,
Yeah.
it very little maintenance. So how great about having this gas cooler if you get it right on the first time, and many people realize this, and we like to share some of our tips, some of the things that would be useful for them.
Yeah, but at the same time, Jemson, you would also agree that a gas cooler, because I mean we have there's many discussions out there. At least I can feel the discussions that more and more hot extractive systems are, let's say, are kind of coming. What does it mean? I mean, in this type of systems, the analyzer in after the sample handling system, so you will still have a gas sampling probe, you will still have the heated sample line, but the analyzer is capable to measure the gas hot. And
yes.
I mean, we must clearly admit that if this is possible, this technology has a super big advantage, right? Because, and this is something we will also discuss, the gas dryer, the gas cooler will change the gas probe. So if all other components like the probe, like the heated sample line, have the task that they should not touch or do any changes to the gas sample, it is the task of the gas cooler to remove the water. And by removing this water, this is really, I would say, kind of a crucial process. And this is also something why these type of equipment, is more complex, than probably. I mean, in the last webinar we discussed the heated sample line, where we always say this is an underestimated item, but it's clearly that the gas cooler is one of the very complex items, right?
That's right.
Yeah, Jemson, maybe you can go to the next slide, and we can this video was something we already shared, but I mean here, and I think that's important. This was also something we discussed in the preparation. For me, Jemson, from your experience, is there a difference between a cooler for process analytics, for process control, process measurements, and emission monitoring?
Yes, there is a couple of significant difference. You see, in the process analytics, what they want is that they want a control. They want to have a control. Therefore, response time is important. It's critical. You see, and the process analytical, there are many times that they are pressurized. They are positive pressure. You see, now on the emission side, we have to reconsider that truly we need a sample pump on the downstream. We have to extract the sample, to siphon the sample, because the spec is slightly below ambient. It is like negative. So therefore, we always need a pump. And second thing that we need to consider, and you see in the emission monitoring, there is a RATA test, a relative accuracy test audit. That in this test, we want to check the reproducibility between an online and the laboratory. Therefore, the sample that goes into the same system for the gas cooler, the time has to be short. You see, it has to be short so that the losses of the soluble gases has to be minimized in order to be representative. So these are the biggest difference, in my opinion, in between the process and the emission. There again, you know, the exchanger is also different. Many people just look at the cooler from outside. They didn't realize that the fundamental, there are many other things that we have to consider. Yeah,
yeah, and this is what we will explain, and this is something we will show here today. Yeah, and I'm excited to give some insights, because this is really what also our request or our idea from this webinar. Yeah, Jemson, before you go stronger into theory, and we will look into the PNID of, let's say, a typical SEM system, maybe just shortly to introduce and to show. No, if you can go one slide back, Jemson. Yeah, I would like to shortly show here, as in the product development or in the solution development here in AGT-PSG, yeah, we have also two different product lines, and that really gives me the chance, or us the chance shortly to explain why do we have these different product lines. So the guys which are surrounding me here, I always say this is kind of a family meeting. The guys who are surrounding me here, this is the MAK family. This would be the right-hand side. This would be the solution for the emission monitoring. And the other product line we have here, Jensen, I have to move the camera, and you have to say if it's accurate. Yes, it is.
Yes,
it is.
Yes,
It should be.
Yeah.
Now, I think it's interesting to show this here is the BCR line. And you already said, Jensen, that there's some difference in the heat exchanger. Okay, now interesting. We haven't explained what is the important components of a gas cooler, and maybe yeah, we can shortly say, on the one hand side we have the cooling power itself, and the cooling in this case comes from in the versions I have here, from a compressor, or thermoelectric from a Peltier cooler. And then, Jemson, that's what you already mentioned. This is something super important. And maybe you can explain why.
Well, I think fundamentally, you know, for a process cooler, was that we are able to take positive pressure. Yeah, and secondly is that not just simply because of how high the positive pressure, but rather, you know, the positive pressure, we can use stainless steels like this, but is the response time, the speed. We can take higher flow rate. When we take higher flow rate, we want the sample, the fresh sample, rather than, you know, the lag sample. We need to have this fresh sample to comes into the sampling system to reach the analyzer in the shortest time, so that the analyzer can respond in the control.
Yeah, and I think at the same time we have the requirement that even if the process, like you said, you have a startup phase, you shut down the plant, there might be a peak or something. So this kind of application, the cooler for the process analytics, must be yeah, as strong as possible, I would say. And therefore, you can see here, this is just an example for the heat exchanger. What does it mean? The hot gas comes in, and there's a cooling rod from copper. There's a copper cooling rod here inside, which makes sure that the cooling of the heat exchanger is perfectly done. And then at the same time, it is important that there is a stable and low outlet dew point. So in the BCR row and with the BCR components, as you can see here, we even have the chance to have two gas streams, two gas paths in one heat exchanger. So there's a lot of power, there's a lot of cooling capacity, and that really allows us, even if there's a high flow and there's a high inlet dew point, this component really allows us to come out with a very dry outlet dew point. Typically, this is what you said, Jemson. We have the peristaltic pumps here. There we use Gardner Denver as our 25 pumps. I think maybe the best and most established peristaltic pumps here. But that really allows us, to have a high flow. And also, we have to be honest, this type of heat exchanger, when you have a super strong cooling, you will also see a lot of washout effects. But like you said, positive pressure, this is possible not only in PVDF, but this is also possible in glass. I mean, this is not good for the positive pressure, but stainless steel, for example, is then something very common. And this is more a version which is used for the process analytics, right?
Mm-hmm. Yeah. So the customers has a chance, for especially for the EX hazardous area. They have a chance of choice of using a peristaltic, or they can use a positive displacement auto drainer to drain the water.
Yeah. Maybe, and we always have, as always, James, we have to have a look at the time. Just shortly, I think this is also the reason why these type of coolers are available for ATEX areas, right? Because sometimes there is no other way than to install a cooler like this into a zone 1 or a zone 2. And then it is important that there is additional safety for the coolers as well, right?
Mm-hmm.
Yeah.
Okay. And the wonderful thing is that we, as a zone 1, a gauge, a display gauge indicator.
Yeah. This is I think that's another big advantage.
Yeah.
Okay, let's go back maybe to the presentation, Jemson, and maybe you can give us a short insight of something which, when I saw this the first time, looked very complicated to me.
Yeah. Is it on your side? Can you switch it to? That's right.
I think it's on your side. If you can you click on? Yeah, there we go.
Yeah. So this is a draft. This is a draft of a complete SAM system. It's only a draft for explanation reason. You see, in the consideration of this sampling system for flue gas, for the analyzer to measure the gas, the sample has to be conducive. You see, it has to be conducive. So what do I mean by that? So in the midst of this whole value of conditioning, we have to minimize the amount of dust, minimize the amount of water, all right? And to avoid cross interference. And going through the gas cooler is to get the dry basis for reporting purpose. And we have to address the acid dew point, especially on the heated line that is above the, normally we take SO2 as a reference. Sometime, the HCl, if you need to measure for some reason, right? So something that many people have forgotten in the sampling system is oil. You see, sometimes you're firing heavy fuel oil, diesel, the sample is oily, and people have forgotten about oil. We have to address to remove and minimize the oil, the tar, the bitumen, right? The controlling the flow rate. And then one important thing that many people also forgotten is the unburned hydrocarbon. How do we know that the combustion is completely, use up all the hydrocarbon? So in the stacks, there are presence of unburned hydrocarbon. And hydrocarbon, especially in the infrared, they are much cross interference. So that means that we have to remove and capture the unburned hydrocarbon before it goes into the gas analyzers. So over here, I like to focus on one point. Today we're talking about gas cooler is the pre-condensate. There are many of these applications that people put a pre-condensate just before the gas cooler. So why? Why that people put a pre-condensate before the gas cooler? The reason is because of they want to remove some impurities, some pollutants, such as tar, which is oil. All right, they are sticky. They don't want to go, downstream to the rest of the component. Sometimes the application on burning some waste chemicals, some chemicals, they want to dispose of chemicals, and you do not really understand the physical properties. By the time it goes to the heated line, and before it goes to the gas cooler to protect the gas cooler, there are some physical property changes from gas to solid again. So in such a thing, we want to do so-called collect it on the pre-condensate. However, the trick comes here. Many people knows the position where the pre-condensate, the location. Yes, fair enough. Yeah, there is one thing that you can add one more point to make your pre-condensate even more useful. All right, by putting the pre-condensate into our gas cooler. You look at the gas cooler on the right side. You see there are two peristaltic pumps. Why there are two peristaltic pumps? Because of first exchanger, we use it as a pre-condensate inside. All right, and then followed by the second exchanger as a. So having this.
Okay, let me get that straight, Jensen. Now we said, because really that fascinates me still until today. We have the hot gas sampling probe, maybe 180 degrees C holding temperature. In the previous webinars, we discussed why this is so important to have a temperature of 180 degrees C, just as an example. And we agreed, okay, this is the asset dew point, which requires a higher temperature. Then the gas flows in the heated sample line and arrives at the cooler. Now you are saying, okay, depending on the system configuration, I think to make this very clear, here we talk about emission monitoring. So we talk about the measuring itself. And now what we do is more than crucial, because we have from the hot gas phase, from this 180 degrees C, you will have a short pre-cooling here, so that there will be no heated the PTFE or PFA, which you are using to connect to the gas sample cooler or to your gas conditioning system, will not be heated in order to have a pre kind of cooling. And then the gas has to come from the hot gas phase to the dry gas phase. And I think, I mean, because you indicated there, Jemson, already a heat exchanger, and I think now it's a good point also to explain why this is so important.
Yeah, you see, many a times, like my past experience, I put the pre-condensate outside gas cooler, meaning that is exposed to ambient temperature. It could be in the analyzer cabinet, which is semi-air conditioned in the house, or it could be outside, depending on summertime or in winter time or whatever the time. The temperature that's surrounding them, the ambient, is fluctuating, right? If you just imagine, if I put the pre-condensate inside the gas cooler, we have a stable temperature, all right, which is much cooler than the outside ambient temperature. Now that the sample comes in, it collected these impurities or contaminants. Same philosophy. It's just that if you were to put in the cooler, it would be much more effective. At the same time, it removes the water. Not only removing the contaminants. You have two functions at the same time.
It removes as a pre-separator. It can remove, especially when you have high amount of water, right? This can really help you in your layout. Problem is only, how do you know?
In fact,
sometimes we get the feedback, that when you choose the wrong gas cooler, you might still have you overrun or you overflow the gas cooler, and at the end you will still have some water left, and this makes you big problems later on then in the analyzer system or in the analyzer itself, right?
Yeah.
So
in fact,
okay, Jemson, if we have a look here at the heat exchanger, because I brought let's say a raw model. Actually, this is a real model of our MAK10 heat exchanger, which is also here in the which I can maybe show here. So special thing is the hot gas comes in. And here, you see, I went to our R&D department and I've stolen all of their materials. Okay, but anyway, I think it's good to understand how that really works. So in the heat exchanger, this here is the cooling tower, if you want to call it this. So this is really this is made from copper, and this is connected to the compressor. And then in this case, we cool from the inside to the outside. The hot gas comes in, it is flowing all the way down. The dry gas here gets out, and the condensate here can be or will be sucked by the peristaltic pumps. I think this is just an important technology really to understand. Another speciality, because James, I think you already mentioned some components which can make life pretty complicated for the material here. And this is the reason why we use aluminium in our heat exchanger. It's an aluminium piece with a very special layout, patented layout, and it is PTFE covered. So that makes the surface of this hydrophobic, because it is really the most complicated item in the sample, in the cooler, because the heat exchanger, you have to make sure that you get or let's say the transformation from the hot gas phase to the cold gas phase. You have to make sure that that the water is removed super quickly, right?
Yeah.
So that there is not a lot of time to get combined and to wash out these suitable components like SO2, for example, right? But at the same time, you have to make sure that there is no corrosion. Because like you said, Jemson, and this is maybe one of the advantages of these cold extractive emission monitoring systems, yeah, they can operate for a very, very long time. Yeah, without the need of any service, right?
Mhm.
But Jemson, to go back to more from an academic point of view, I think, and we agreed that this webinar should not only be presenting our products and solutions, but um, actually, I can think of two things which are better than a typical gas conditioner, a gas cooler. Or I can think of two technologies which will avoid the loss of any SO2. So
Mhm.
maybe the first one, I think you prepared a slide, right?
Mhm. Mhm. Yeah. What I did is that what I'm going to do is that let me go through a couple of slides, then we will talk about the
Maybe you
washout.
show maybe you show the next slide. I think it's already on there.
Yeah, yeah,
Yeah.
yeah. Well, I mean, this slide is to tell us that for those people who buy the gas cooler, we
Sorry.
also have to take into consideration about the the application. If you are doing an application an FGD, the flue gas desulfurization, you have to find out what kind of is a dry application or the wet application. If you're talking about a wet application, normally they're going to use water using as a caustic or sodium hydroxide. All right, so to remove the acidic flue gas by neutralizing it by injecting alkaline. So once that flue gas become alkaline, all right, it can easily wash out. So if you are measuring SO2 for the efficiency, all right, the same gas cooler, you can actually use one of the pump as an acid dosing pump, all right, to again bring the flue gas back to acidic, right, to
Hold
do
on.
for
That
measurement.
mean that okay. That means what we technically do inside the cooler, we add acid into the measurement, and so that makes the gas sample, yeah, containing so much acid that it is not going to lose, or it will only lose very, very rare components of SO2. Is this that what you're saying?
Yes, yes, yes.
Ah,
So we
okay.
can inject phosphoric acid uh, into the inlet of the sample before
Hmm.
the sample introduced into the exchanger.
Right.
Yes. So
Right.
the second exchanger, the second peristaltic becomes a condensate pump. Yeah. So we can have
Okay.
it looks alike, but the speed we use are different.
Okay.
Yeah.
Okay.
Yeah.
Yeah, I understand. Jensen, hold on. Before you go to the next slide, this is again one of my very loved one, unprepared and not discussed before questions. um, to be very fair, I can think of another system which has no SO2 loss.
Mhm.
Do you know what I'm talking about?
Yes, yes, yes. Yeah. Are you going to present it now? Please,
No,
you
no, no.
know.
I'm
Yeah.
no, no, no. No, no. I think we have not prepared a slide, but
Okay.
to give a complete picture, I
Uh-huh.
think we have to discuss Nafion or Permapure,
Okay.
um, because yeah, fair enough. There's another technology. Maybe you can explain this a little bit, Jemson, if you are
Okay.
prepared.
No, generally, there are. I mean, there is an alternative. Mm, it's not so much about this the application, but it's only for the same objective, is to remove water. All right. So in the Permapure, they're using this Nafion uh, exchanger, and this
Mhm.
chemical coated capillaries. So
Yeah,
in order for the
it's a
Nafion,
membrane. I would say the Nafion is a membrane, right? It's a little bit
yeah.
comparable to Gorotex as a component, and
Mhm.
we must admit this technology really also has no SO2 loss, right? because yeah, with this technology, you can remove SO2. No, you can remove water from the gas stream without any SO2 loss. But at the same time, you have to admit that the Nafion itself, yeah, reacts on certain other components, and this is not as service-free as these type of items are, because we must really admit that from all coolers we have running and operated, like you said, Jimson, I mean, the components which are used here, no matter if it's thermoelectric or if it's really the compressor cooler, the compressor, it just runs like in your really like in the refrigerator at your home. So
in fact,
but I think it's important to mention that there's a technology which has certain advantages, like no SO2 loss, and they also have a super low, even a negative outlet dew point. But yeah, it always comes with some disadvantages. You just have to be aware of. That's what I'm trying to say.
Yeah.
Okay. Yeah, but
just,
sorry, I disturbed you again, and I'm crashing on our agenda here.
Okay, so yeah, so I'd like to show you. You know, this is another schematic drawing, different from the first one. This is a gas cooler with dual exchanger. Yeah, with dual exchanger, whereby in between there is a sample pump. Yeah, this is something we like to stress in the backdrop of our gas cooler. Many times we have no idea where our gas cooler landed. We sell it to system integrator, and the system integrator has so-called commission, and then they will install in certain area. We have no idea. And we also have no idea how they do the configurations and what type of samples are they using. So all these things are known factor now giving me an opportunity to stress that, having this configuration, like having a gas cooler with dual exchanger is always encouraged. It's always encouraged because the first exchanger, right, the green color on the left.
Next slide, you give a very good overview, James. Jump to the next. Yeah, that's nice.
Okay. Yeah. So the first.
I was cheating. Okay.
Yeah. Many times, it's always good to oversize the sample pump. All right. If I would be the system integrator, I also wanted to oversize the sample pump to be more to buffer. There's any of this needed additional flow. However, having an oversized sample pump, sometimes we overlook that it oversized so much that it actually exceeded our gas cooler specification. All right, that when the capacity is over, the sample was so fast, the flow rate that it passes through, and you can see that water carry over like this.
That's so right. It is always, so you would say this is a backup kind of thing. Technically or theoretically, if the first heat exchanger would do a perfect job, whatever a perfect job is, that there would not be a need for a second heat exchanger, but you would always recommend to have to just to make sure that it's really dry afterwards, right?
Yes. Because after all, you're investing in a gas cooler. Why not just add a few couple of dollar or euro to add a second exchanger into it?
Yeah.
All right. Yeah. It's much more expensive. After commissioning, then you recognize that, oh my God, something happened, and then you have to attend to it. The amount of man hour and the trips, they cost you much more. For that reason.
Yeah, absolutely. I understand. And we have to admit, this is a little bit different to the thermoelectric or Peltier cooling. In general, compressor cooler have a relatively high cooling capacity, caloric capacity, which means they can easily even handle 2 gas pass or 2 heat exchanger at the same time, and this is maybe a big difference there. Jensen, if I mean, I'm not sure. I really hope that we could clarify why it is so complicated, why especially the heat exchanger inside of a sample gas cooler makes the development of a product like this very, very complicated. But I think it's important to come back a little bit and to understand. So, except performance and let's say and low maintenance and all these kind of attributes, we can say the two most important characteristics, especially in the field of emission monitoring systems, would be outlet dew point and washout rate. Yeah,
Yes.
would you agree to this?
Yeah, stable outlet dew point.
Stable and low outlet dew point, or stable outlet dew point? What would you say?
Stable and low outlet dew point.
Yeah, You're right. You're right. Yeah. Now, I think because this is something also to give the audience a little bit insight of our, R&D and of the activities we are doing here. The MAK10 heat exchanger, which we are sharing here, is very strong, I would say, in an overall performance. That really means it is flexible if you have a higher flow, and it will always come out with a low and constant outlet dew point. But at the same time, because it's always remember when we discussed this graph, it's always a dilemma. Theoretically, you could use a super extreme heat exchanger like the BCR guys, like the ones from the BCR.
Heavy duty.
Yeah, heavy duty. So you force the gas to get super dry, yeah, but at the same time, you will have a very high washout rate. And in emission monitoring, I mean, for process analytics, you don't care too much about the washout. So this is the perfect heat exchanger, and this is the perfect solution there. But whenever we talk about the gas cooling and the gas drying, it's a compromise between cooling, meaning low and constant outlet dew point, and washout. And I think that really gives me the chance to introduce also here. I think, Jameson, we prepared a slide for this. That really gives us a chance to introduce the newest development here from us. Which will be the MAK20. And in the MAK20, we use a so-called jet stream heat exchanger. And with this heat exchanger and many hours of development and testings, we realized that there is a big improvement possible. I mean, this technology itself is established in the market for pretty long already, and there's several advantages you will have with this new designed heat exchanger. One of the advantage is, because sometimes we get this as a feedback. Let me maybe make this a little bit bigger. Here you have the chance, you have direct access to the heat exchanger. So if you want to remove the heat exchanger, you don't need to open the cooler, right? But at the same time, we managed that this cooler can be operated standing somewhere, like it does here, or if you want to install this, for example, you have the chance to access the heat exchanger here, even from the outside. Yeah. This just gives you some very good options to operate the heat exchanger, the jet stream heat exchanger. Here you see it's 2 ways, so double heat exchanger also here in the system, and that really gives you a lot of variety how to operate with this cooler. And we are very proud to have this new development, and that really reaches an outstanding performance in terms of SO2 washout, but also constant dew point. So that really covers the newest development. Another point we also want to mention, but Jameson, I think again as always we are short on time. is the options. From your experience, because when we talk to customers, it's kind of a controversy. It's a kind of a discussion. What is the best solution? Jameson, from you, would you integrate components like a depth filter or the gas sample pump inside, or would you leave it outside?
I would put all the components. We call it a. You see, many people, including myself in the early days, that when I work in the gas analyzer company, I leave my projects to the system integrator. And many years later, then I recognize until I joined the sampling companies. You see, when given 2 drawings, the same drawing for 2 different engineers to put a system integration, exactly the same, they follow it, nothing goes wrong. There is one thing that obviously different is a connection. Some people have made, between the gas cooler and the filter and the sample pump, they are far away. Maybe they are 0.5 meter away. And this causes open to a physical property changes between it change back from the liquid to gas or gas to liquid, depends on the ambient temperature. Therefore, I encourage that if you have a choice, all right, look into the gas cooler with an integrated that include the condensate detector. They can have this pump that is putting outside. It's always encouraged to put outside, but make sure that the pump is above the gas cooler, not below the gas cooler. It has to be above the gas cooler, and the filters plus the flow meter, so that we limit this expose of the naked Teflon tubing. All right, does not allow it to have this impact by the ambient temperature. So that is very encouraging to do it.
Okay, right? So like often in life, you say inside or outside, and you answer it depends, right?
Yeah. I always encourage to have the like the one in the photo here. We can put not only the condensate, but the full integrated air conditioner, the filter, the flow meter, the condensate in one.
Maybe you can show the options just shortly, and then we're running. We have to have some time for the Q&A sessions. Jameson, if you can move on your presentation, I think you gave an overview of the different options which are available there. To go on, go next one to the end of the presentation.
Yeah. So this is the example of gas conditioning.
No. If you go, sorry, Jameson. If you go to the end of the presentation, the last slides, I think we showed. Yeah, hold on, one back, one. Yeah, that gives an overview. Or if you go one slide back, this is just the different options which are possible to be integrated, and then the gas cooler itself becomes a gas conditioning system. But at the end, everyone has to decide. There's disadvantages to put the gas sample pump inside, because in this case, if you need to service the pump, you have to open the cooler. You have to open the housing. But like I said, that always depends. Okay, Jameson, I think only 1 minute left. Is
I like
there
to
any?
answer. Yeah,
Please.
some questions from the audience. You say how to clean the exchanger. Now, I like to say this way: depend on the model. Depends on the model. You know, applying whether from other supplier or let's say for us, depends on the model. We can just remove the exchanger from the top, and then you just wash it. Another option, if you do not want to do that, you can use again phosphoric acid. You reverse the peristaltic pump. The tubing of the peristaltic pump is supposed to pump out. You reverse it, you are actually pushing the phosphoric acid back into the exchanger and push out all the contaminant. This is a one way of washing the exchanger.
Okay. All right. Jensen, I think it's 10 o'clock. I'm sorry. I really think we have to be a little bit timekeeper. Let's do the following, Jensen. As you said, we want to have a webinar at the end of May, which is, you know, wrapping up all of this.
6 months.
The audience, we really promise you, we will take your questions. We will take the questions you are raising. We will take your feedback and the information you gave us, and we will answer this. So in this webinar, then we will have more time for the Q&A parts. And even if you have some question, you can drop us a private message. We will make sure that in this webinar at the end of May, we are going to cover this. Yeah.
In the next fortnight, you see, we have been doing this webinar for 6 months. By the end of next fortnight, which is the last Thursday of May, that we please look out that we are going to summarize the entire 6 months. The critical point.
We will party.
We'll party. yeah. Just look out for the day. Join us.
We will make a party, a vaccination party. Hopefully, this situation is also getting better. Jensen, thank you so much. I think next webinar we will have Tobias again here with us. He was so kind and helped us with the infrastructure and the backup. Again, it was a lot of fun. I really enjoyed this again. And you guys all take good care, stay healthy, and see you in 2 weeks, right?
Yeah, next Thursday.
Bye bye.
Next fortnight. Goodbye.
Bye bye, guys.